So we want to find the first thing we want to do before anything else is we want to find the possible rational zeros of each function. Alright? So the first thing that we need to do is we need to find the factors of the constant, which is negative 60, and the factors of 6, which is our leading coefficient. Alright? So we represent the factors of our constant with the letter P. So we're going to have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 12, plus or minus 15, plus or minus 20, plus or minus 30, plus or minus 80. Right? And then find the factors of our leading coefficient, which is
Excuse this interruption. Daquan Taylor, please come to the attendance office. Daquan Taylor, your attendance, please.
plus or minus 3, plus or minus 6. Alright? So, after we have that, we actually need to find the possible rational zeros. We have not found the possible rational zeros yet. Right? We have not done that. All we have done is put ourselves in position to find the possible rational zeros. So, in order to do that, what we have to do is we have to take each of our factors of P, or of our leading coefficient, and divide them by each of the factors of Q. Okay? So, what we have is, we have to go P divided by Q. Alright? So, we have, so what you do, you have 1 divided by 1, 2 divided by 1, 3 divided by 1, 4 divided by 1, 5 divided by 1, all of these divided by 1. That is going to be just all of these repeated again. Alright, I'm going to cheat. Number 1 and 2, just copy and paste. Right, that's all of those. Then, what we have to do now is we have to take each of these and divide it by 2. 1 divided by 2 is 1 plus or minus 1 half. 2 divided by 2 is 1. 3 divided by 2 is going to be plus or minus 3 halves. 4 divided by 2 is 2. 5 divided by 2 is plus or minus 5 halves. 6 divided by 2 is 3. 10 divided by 2 is 5. We already have those. That's why I'm not writing out of them. 12 divided by 2 is going to be 6, which we already have. 15 divided by 2 is going to be 15 plus or minus 15 halves. 20 divided by 2 is 40. No, 10, which we already have. 30 divided by 2 is 15, which we already have. 60 divided by 2 is 30, which we already have. Then I'm going to do the same thing again. 1 divided by 3 is plus or minus 1/3. Alright? 1 divided by 6 is plus or minus 1/6. Alright? Oh, wait. Yeah, no, not one. I've done 2. Yeah, 2 divided by 3, which is 2/3. 3 divided by 3 is 1. 4 divided by 3 is 4/3. Alright? 5 divided by 3 is 5/3. 6 divided by 3 is 2. 10 divided by 3 is 10/3. Alright? 12 divided by 3 is 4. We already have that. 15 divided by 3 is 5. We got that. 20/3. Alright? We also have 30 divided by 2, which is 10. 60 divided by 3, which is 1. Alright, so that's some more. 1 divided by 6. That is plus or minus 1/6. 2 divided by 6 is 1/3. We already got that. 3 divided by 6 is 1/2. We already got that. 4 divided by 6 is 2/3. We already got that. We don't have 5/6 yet. We do, so let's see, we go from there, we have 6/6, that's 1. 10 divided by 6, that's going to be 5/3. 12 divided by 6 is 2. 15 divided by 6, we already got that. That's going to be 5/2. 20 divided by 6 we'll have, 30 divided by 6 is 5, 6 divided by 6 is 10. We have them all now. Alright, now here's the thing. I heard Michaela say it in her homework. She went through a bunch and took a long time. And it can. Because this polynomial can have how many zeros? It can have up to, it could have 4 rational zeros. Right? It has 4, but they might not all be rational. But here's what we do know. Until I find 4, I would have to keep testing all of these. And that is 1, 2, that's a lot. Alright? A lot of times you have to keep testing something. You have no idea where to go to start. Alright? So, what right now is the best thing for you to do is to, well, is to actually make your calculator up. Alright? And what we're going to want to do is we're going to want to take our calculator and actually look at the graph. Not find the actual zeros, but you know, if we look, we could have a decent idea of where these zeros are. But I still want you to find them by hand. Hopefully coming up. Alright. So, we have our calculator where the y equals 6x to the 4th plus 13x to the 3rd minus 67x squared minus 156x minus 60. Graph. Alright. If I look at this, alright, what I see is that it appears that I have some zeros. Well, we can see where my zeros are. I have a zero right here that's somewhere between -3 and -4. I have a, and it's not, it isn't, it's not negative, no, yeah, it's not -3, and it's not -4, somewhere in between. I have one that's between -1 and -2. I have one that's between 0 and -1, and I have one that's between 3 and 4. Alright? So, by looking at this graph, I can, you know, sort of eliminate some of things. So I know this is not, plus or minus 6 is not going to be 1. Alright? No, 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 no. That's 1, no. 1, 2, 3, 4, so. Alright, so could be some of these, could be like those. And we actually know it's none of these, because none of those actually fall on the exact one. So we could have -1/2. We could have -3/2, because we have one that's in between -1 and 0, so -1 and -2. This is -2.5. That'd be like here, so there's not, that's not 1. 15 over 2, that's going to be like -7 or 7 or something, so no. And -1/3 could be a potential. -2/3 could be a possibility. -4/3 could be a possibility. 5/3, that's going to be 1 point something. So this negative could be something. 5, 6, no. So that could be negative. we have some ideas we could possibly have. And then 10/3 is what, 3 point something, so it could be that.
Alderman Van Goren, please come to the main office. Alderman Van Goren to the main office. Thank you.
So by looking at the graph, you would just sort of rule out a bunch of it. Right? Now I'm going to start right here. That looks pretty close to -1/2. Something like that. So I'm going to start with doing synthetic division with -1/2. You go -1/2. Alright. I'm going to have 6, 13, -67, -156, 60. Right?
Michael Simon, please come to the main office. Michael Simon and Alderman Van Goren to the main office. Thank you.
I'm 36 now. -1/2 times 6 is going to be -3. So that's going to be a 10. -1/2 times 10, that's going to be -5. So that's going to be -72. -1/2 times -72, that's going to be what? 30. Negative times negative, that's going to be a positive 36. That's going to be -120. -1/2 times -120 is positive 60. That's 0. So that tells us that since we go through all that, we get a remainder of 0. That x equals -1/2 is one of our zeros. Questions about that? Did the calculator give you that? Yeah. Of course it did. Alright. Now, let's look at this. Let's look at this. This right here. That looks like what is -2.5 be? That'd be alright, so let's look. We have -10/3 would be what? -2.3. Let me look at that one. No, did you find the other one? And 1.66666. Where? This? That's -1.6. So, oh yeah, right here, -5/3. So let's look at -5/3. That's why I get them right here. So what we do, alright, we have -5/3. You're going to bring down 6, 10, -72, -120. Bring the 6 down. -5/3 times 6 is going to be -30 divided by 3 is -10.
Move your assignment, please come to the main office. Move your assignment to the main office.
Alright, -5/3, and you guys can do the multiplication on the calculator. Maybe you times 0 is -5/3 or 0. That'd be -72. We're going to have -5/3 times -72. I believe this is that's going to be 2, 3, 121. Yeah, 120, so it's going to be 120. When you do -5/3 divided by -72, it's going to be 5/3. So -5/3 times -72 is 120. What is? That one. Oh, wait. Where are you going up from? Yeah, should have been here. You take these ones. You don't use the original ones. So, if x equals negative 5/3, that is also a 0. Alright? Now, that point, remember what we talked about. The initial degree of this function was 4. Alright? And we divide this, we find a 0. That means we're factoring something out. So this degree right here would be to the third power. So you have 6x to the third plus 10x squared minus 72 x minus 1 1. Alright? Then down here, you have 6x squared plus 0x minus 72. Once you get to a quadratic expression, right here, right? We're done with that other stuff. Alright, so we're done with the division. You have 6x squared minus 72. Okay? The reason we're done is because if we get down to a quadratic function, and any of these other things are zeros, we'll be able to factor this and actually get the answer quicker. Alright? I know I can take this, I set it equal to 0. 6 times, that'd be x squared plus 72 divided by 6. That would be 1, 12, 12, 12. Alright? And what I see here is that eventually I'm going to get x squared is, I set this equal to 0, be x squared minus 12 equals 0. And get x squared equals 12. X equals plus or minus the square root of 12. And what I know is that this is not a rational number. Since this is not a rational number, I know that none of these other things are actually zeros. These are the only two rational zeros. The other two zeros are non-rational, meaning they're going to be decimals that aren't actually at this fraction. The next question would be, what part is the part that has this one? Last part was when you went through your dividing about the order of the divided. What do you mean? Because you went from 1 divided by the first thing about. Like, where should you start? Yeah. Okay. If there's not a lot of them, like there's maybe like 5 things, if there's only like 3 things, but it actually be 6 if plus or minus, and there's actually 6 of them, I would start with plus. I would start positive 1. I would start with negative. All right. In this case, since there's so many, that's been well. Now, yes, because right now you lose that, and no one wants to actually try that. Like, what's going to happen is this. No one wants to work with fractions. You would have tried all of these, hoping to God that you got something. And then you would find out you wasted all your time with all of those numbers, and you're like, well, now I got all these fractions. Yeah. Because you do, so you get the plus minus 1/2 of them, positive 1 and negative 1 divided by positive 2 and negative. So you get plus minus 1/2. I just didn't know which one to apply from. It is right, it's not on the graph. So looking at the graph helps. Now, what we're going to learn about is different ways to figure out how to eliminate some. Because obviously you can see there can be a bunch of things you need to look at. Right? So the question would then be, how do we actually figure these out? How do we, without using a graph, how do we eliminate a bunch of them? Right? There's really 2 ways to do that. Now, let me just see. How many of you guys got your homework done? look at number 3. Or number 13. Alright, so how about I want someone to read off to me what number 13 says.
4x cubed minus x squared 9x squared
4x cubed minus 9x squared. Let's take what one?
minus.
Alright, so first things first, we need to find the factors of our constant. Our factors of our constant are going to be plus or minus 1. And our factors of our leading coefficient are going to be plus or minus 1, plus or minus 2, plus or minus 4. Sounds good, doesn't it? Everyone's good at this part. Okay, so now what we need to do is we need to find our possible rational zeros. Possible rational zeros. To find our possible rational zeros, it is p divided by q. Right? So, what we do, we only have one value for our p plus minus 1. So it's going to be 1 divided by 1, which is going to be plus or minus 1. 1 plus or minus 1 divided by positive and negative 2. That's going to be positive and negative 1/2. And then positive and negative 1 divided by positive and negative 4. It's going to be positive and negative 1/4. Alright? Questions about that so far? So if I ask you to find the possible rational zeros, and that's it. And that's just how we represent it. Alright, so that does not mean that those are our rational zeros. They could be, but they also might not be. Let's figure out which ones are. So, question. So what we do, looks like we have a minus sign right here. Alright, I'm going to test. I always start with 1. Alright, I always start with 1, so just because it's always the easiest one to work with. So I have 1, and I'm going to take my coefficients 4, negative 9, 6, negative 1. Bring the 4 down. 1 times 4. 4. Negative 9 plus 4 is negative 5. 1 times negative 5 is negative 5. 6 plus negative 5 is going to be positive 1. 1 times 1 is 1. Negative 1 times, or plus 1 is 0. Alright? So, we completed that. Sean, you look puzzled. What's up?
Question. I'm like,
Yeah, the question.
yeah, I was stating something.
Oh, so you're going like synthetic division?
Yeah.
Yes.
Not.
Alright, good. So yes, we're using synthetic division here. Now, here's the thing that I noticed a few of you guys doing. Okay, so you do this synthetic division, you find out x equals 1 is a 0, you put a check mark next to it, good. Alright. Now, I want us to make sure we understand what that is. Alright. So if x equals 1 is a 0, that means that x minus 1 is a factor. Alright. And right here we have these 3 numbers represent the 3 new coefficients of our factored polynomial. So that's going to be, always drop it 1 degree. 4x squared minus 5x plus 1. Okay? So at this point, you have 2 options. You can either factor, which is the option that I typically would choose, or you can keep using synthetic division if you are comfortable with factoring, which is both are fine. They're both going to get you to the same answer. Alright, so what we're gonna do, so I'm not gonna factor. Alright, if I take a random guess, I think there's a few of us that struggle with factoring, so I wanna do something that we're all comfortable with. Alright, so after this, we've done synthetic division once. Alright, we know that positive 1, alright, is a 0. We're going to choose another one. Alright? Personally, I would, since I have fractions, I would choose the fraction that has the denominator that's the same as this first number. Why? Because I know that's 1/4, I know that, but I'm multiplied by 4, it's going to give me 1, to start giving me nice numbers right off the bat. Alright? So, I'm going to try 1/4. I could try -1, but I don't feel like wasting my time. I know -1 is not my case. Alright? So, now, here's another thing. When you do this, okay, it is important, when you do synthetic division for the second time, that you do not use the original coefficient. You can, it's not going to help you at all. Because it's still going to give you, it's still going to tell you that this is a 0. But what happens is it doesn't decompose, it doesn't break down the polynomial. So you're never going to get to the point where you can stop. You're going to have to keep testing all the numbers. Alright? So I'm going to use 4, -5, 1. I bring my 4 down. 1/4 times 4 is positive 1. -5 plus 1 is going to be -4. 1/4 times -4 is going to be -1. That's a 0 because I add them now. So that tells me that 1/4 is a 0. Okay? Are we good so far? Alright. Now, I can do synthetic division again, but here's the thing. This right here, so I started with an x cubed. This is x squared now, right? I now have this as being, now I have x minus 1 as a factor. I have x minus 1/4 as a factor. And then I have 4x minus 4. Because it went from being cubed, squared, now it's a linear term. 4x minus 4. So what is my other 0? Well, I take this last factor, 4x minus 4, and I set it equal to 0. Alright? I add 4 to both sides. I add 4 here. I get 4x equals 4. I divide by 4. I divide by 4. I get x equals 1. So my zeros are 1, 1/4, and 1. Now, here's the thing. You guys are seeing the answer key. It says like 1, comma, mult, period 2. Right? Mult stands for multiplicity. Right? Yeah, I get you notice. Alright, now, you know how we said this polynomial is a third-degree polynomial. That means it has how many zeros? It has 3 zeros. Alright? Sometimes zeros repeat themselves. Alright, like in this case. X equals 1 repeats itself. Alright? And when you're looking at the graph, it looks a certain way. So if we were to graph this, y equals 4x to the third 4x to the third minus 9x squared plus 6x minus 1. Alright, we're going to graph this right here. And then we will take the graph. Let's zoom in real quick here. Zoom in. what we did is here. First of all, we said x equals 1/4 is 0. Okay, there it is right there. Crosses the x-axis right there. We said x equals 1 is a 0. There it is. Now this, what happens here is this 0 repeats itself. It happens twice. X equals 1 here and x equals 1 there. So what we say is it has a multiplicity of 2. So you might want to write this out. Multiplicity means how many times does the 0 repeat? Alright? So multiplicity is the number of times a 0 repeats. Again, the multiplicity is the number of times a 0 repeats. Alright? So in this case, like the 0 found. I guess you could call it. Alright. So what we notice is, okay, we have a multiplicity of 2. We'll talk about this a little bit more on Wednesday. Is if it passes through, like try to zoom in just right there, that's going to end up looking like a straight line. So this 0 has a multiplicity of 1. It's only repeated one time. Happens like this. This 0, if I zoom in, it kind of looks like a parabola. So it has a multiplicity of 2. Alright? So what we see here is, we have our 3 zeros, one of which has a multiplicity of 2. Alright? Questions about that? Alright, so your homework for tonight is to finish what you had for homework for previously. If you had trouble with that, alright, finish it. If you finished it already, then what I would like for you to do is to, if you're able to, take pictures of it and upload it to Google Classroom. I believe I put the assignment there. I'm not 100% sure. I'm pretty sure I said something like that. So there's something there for you to upload that. When you're working on that homework, I know there's some really big numbers there and stuff. You can use your graphing calculator to sort of figure out where the zeros are. That way you don't have to check every number. And actually, use your graphing calculator to sort of make an estimate, see which numbers would possibly work, and then go from there. On number 9, alright? It's the same thing, synthetic division. You're going to do it one time, you're going to get a 0. You plug that 0 into the other little numbers in the picture. Alright, that number that you find is equal to h. So you plug it in and find out the values of the box. Alright? So, let me make sure you have everyone in the gym. Any other questions? Probably.